Hello, and welcome to our next lesson on multiplying and dividing decimals. So there are some important rules we need to know about when multiplying decimals. First thing we have to do is to remove the decimals and multiply the numbers. The second thing we need to do is to place the decimal point. And to do this, we're going to add the number of decimal places in both factors to find the number of decimal places in the product. So remember yesterday when we were adding and subtracting, we were looking at things like this and lining up our decimal place. We were lining it up vertically. We were aligning it. Whereas here, if we are multiplying something like 1.2 and 2.56, we're going to ignore the decimal altogether and just write it as 256 times 12, for example. And then we'll add that in at the end. So let's practice. Find the product of 3.47 and 2.3. Product means multiply. Product means multiply. So we're going to multiply these two together. So I'm going to drop the decimals and write these two numbers as a simple multiplication problem. 347 times 23. So to multiply, I'm going to do 7 times 3 would give me 21. So the 1 goes here and the 2 comes up here. Then I'm going to do 3 times 4 is 12, and then add what I had put up above that. So 12 plus 2 is 14. So I've got 4 and then carry the 1. 3 times 3 is 9, plus 1 is 10. For my second row, I'm going to fill in a 0, and then I'm going to multiply this way. I'm going to do 2 times 7, which is 14. I'm going to cross that out so I know which one I'm working with. 2 times 4 is 8, plus 1 is 9. And then 2 times 3 is 6, plus 1 is 7. So when we add these together, I'm going to start from the right and we get 1, and then 4 plus 4 would give us 8, 9, and 8. So to determine where the decimal place goes, I'm going to look back at the original numbers and I'm going to count how many digits are there total after the decimals. So we've got 1 number after the decimal, 2 number after, and then 3 numbers after. So that means I'm going to start from here, start from the right, and move my decimal 3 places. 1, 2, 3. So my final answer would be 8.981. And that's what we do there. So some properties of multiplication. Some of these are going to look pretty similar to the properties we looked at yesterday for addition. But we're going to say that the property for multiplication is that, or the identity property for multiplication is that if the product, or if we multiply 1 and a, really a could be any number, it's just going to give us a. So for example, if I do 1 times 5, I get 5. It doesn't matter what I'm multiplying 1 by, I'm going to get the original number. The 0 property says that the product of 0 and any number is 0. So 0 times 5 is 0. And it doesn't matter what I multiply 0 by, it's going to give me 0. Even if I multiply it by 1,000,000. And then the commutative property, we talked about this one yesterday for addition as well, says that changing the order of the factors does not change the product. So again, thinking about those M&Ms, doesn't matter what order I put my M's in, I'm still going to get M&Ms. I'm still going to get the word commutative. And so if I do 2 times 3, I get 6. But I could also do 3 times 2 and also get 6. Not too bad. The final one is associative property. And again, we looked at the associative property yesterday. If we group the first 2 things that we're multiplying together, we get 1 times 2 is 2, and 2 times 3 is 6. If we do 1 times parenthesis 2 times 3, Notice that the only difference here is where the parentheses are. We get 1 times 6, because I'm doing 2 times 3, and then we just get 6. Those are the same thing, and that is an example of the associative property. So use the properties of multiplication to find the product of this. So we've got these numbers being multiplied together, and we can do this with using mental math. So what I'm going to do is I'm going to say, okay, 0.5 and 8.96, those would be difficult to multiply together. But 0.5 and 2 would be easier to combine. So I'm going to use the commutative property here to say I know it doesn't matter what order I put these in. So I used the commutative property to switch 0.5 and 8.96. You could have also used it to switch these two around. It doesn't matter which ones. And then I'm going to use the associative property, and I'm going to group what I want to multiply together first. And I'm going to get this. Remember that we can use an X for multiplication, but we can also use what looks like a little bullet point there. That also works. All right, so now I can do 0.5 times 2. Well, 0.5 times 2, 0.5 is the same as a half. So half of 2 is 1, which means I've got this. And then I can say, wait a second, but I know that multiplying something by 1 is just going to be that something. That's the identity property. But notice that I'm labeling my steps as I go. This is something that you'll have to do today as well. And there you have it. For dividing decimals, couple steps. The first one is to multiply each number by 10. What that's going to do is if we do 4.2 and we multiply it by 10, that just is going to move that decimal one spot to the right. And it's going to make it look like 42 instead of 4.2. Place the decimal point in the quotient above the decimal point in the dividend. And we're going to look at what that means. Find the quotient. Quotient means divide. Of 37.92 and 5.4. Well, we're going to multiply each number by 10. So it's going to move each decimal point one spot to the right. So it's going to look like we have 379.2 divided by 54. Now, the number that comes first goes inside the division. And then the number that's second goes outside. And then And then that second step said to go ahead and place that decimal point in the quotient above the decimal point in the dividend. So we're going to put that right there. So now we're going to do this, and we're going to see how many times does 54 go into 379. And we are going to have to use some mental math here. Yes, we could use a calculator and see, but it's good practice. So 54 does not go into 3, it doesn't go into 37, so I have to look at 379. So if I check 54, let me just try times 6. Well, that's going to give me 24. That's 30, 324. I might be able to get a little bit more out of that. So let me do 54 times 7. That'll give me 28, 35, 36, 37. Hey, that worked. I was only one off. So I'm going to say 54 goes into 379 7 times. And then I'm going to do some long division. 7 and 54 multiplied to 378. I don't have to work it out because I already did it over here. Remember that we subtract those. And when I subtract this, I get 1. Bring down the 2. And now I'm going to say, how many times is 54 going to 12? It doesn't, so I'm going to say that it gives us a 0. I didn't mean to put the 0 there. Well, 0 times 54 is just 0, and I'm subtracting those, so I get 12. But I need to keep going, so now I am going to put another 0 here, this time correctly, and bring that down. And I want to figure out how many times is 54 going to 120. Well, let me try 54 times, let's try times 3. That would give me 12, 15, 16. That was too much, so let's try 54 times 2. I bet that'll work. So that would give us 8, and then that would give us 10. So it goes in 2 times, and if I multiply those together, I get 108. And when I subtract those, I have to do some borrowing. I'm going to get a 2 and a 1. And now I have a problem because I have people who ask me, Miss McFall, when do I have to stop filling in zeros and stop trying to end the decimal? I'm going to say that I notice a pattern here. I have the number 12 right here, but I've got it again right here. And so what's going to happen is I can keep simplifying, or keep dividing, excuse me, but I'm just going to keep using these same numbers, which tells me that this answer up here is going to be my final answer. It's just going to be repeating itself. So we are going to see this happen. 0, 2 is going to start repeating over and over, because I'm going to say 54 doesn't go into 12, so it's 0. Bring down the 0, 120, it's 2. It's going to be the same thing. So my final answer is 7.02 repeating. If you get to 2 decimals or 3 decimals in and you're not seeing a pattern, that's okay. I'm going to say you can go ahead and end it. You don't have to finish it out to like 8 decimal places. But see how far you can get. All right. Olivia bought 3 tickets for a concert for $107.91. So remember, the first thing we want to do is see what is the problem asking us. And I'm going to rephrase this one. How can I rephrase the question that they're asking? How much did each ticket cost? What's another way that I can say what I'm trying to find? I can say I'm trying to find the cost of each ticket. Well, I know that each ticket probably costs the same amount. They probably didn't spend different amounts. And I know that she has 3 tickets, so that's an important piece. And I know she spent this amount. So what we can do is take the dollar amount and we can divide by how many tickets there were. My friends and I do this when we go to the movies all the time. Someone pays and then we figure out how much we each owe them. So I'm going to multiply by 10 or move my decimals. And I'm going to say, okay, I've got $107 and, or sorry, well now it's going to look like 1,079.1 divided by 30. And now we can do some long division. Oh, sorry. I'm just trying to switch up a little bit. 30 does not go into 1, it doesn't go into 10, so I have to look at 7. I can say it goes in 3 times, and if I do 3 times 30, I'm going to get 90. So when I subtract those, I get 7 minus 0, 10 minus 9, and I'm going to bring down the 9 and say how many times does 3 or 30 go into 179? It's probably going to go in 5 times. Because if I do that, I'm going to get 150. Subtracting those, I'd get 9, 2,